The second half of these calculations in this area and perimeter have more to do with perimeter or the sides of a shape. Particularly, we're going to be focusing on triangles. And the triangles that we're going to look at the most have a right angle in them. So we're going to be doing right triangles. Awesome. So here's the idea with a right triangle. When you have a right triangle, you actually have this relationship where two squares added together equal the third square. So all you got to do is figure out which piece goes where. Well, here's the clue. This piece is the hypotenuse. And wait, how do we know what the hypotenuse is? It's across from the right angle. So I'm going to put an x squared there. The other two numbers are going to go on this side, 5 squared and 12 squared. That gives me 25, 144, and those added together would be x squared. Okay, 25 and 144, those add up to 169. So the answer is 169, right? Well, not exactly, because notice that this is x squared, and this over here, let's highlight in a different color because it's different, is just x. So how do we get x from x squared? In other words, something times itself is 169. Well, to do that, it's just square root. That's the kind of calculation you would do. And you could do that with your Google calculator. Square root of 169 is 13. So that equals x, 13. That was it. Okay, 18, very similar, but you just got to know which piece goes where. Something squared plus something squared equals something squared. We have a 6, 8, and an x. The x is the hypotenuse, so we're going to put that piece by itself, but be prepared because sometimes the leg will be the missing piece and you got to do a subtraction in there. So this would give us 6 squared plus 8 squared. That's 36 plus 64. And if I add those together, that gives me 100. And again, I have to do that square root thing. So I got to figure out what times itself equals 100. It is, in fact, 10. Okay, so down here it says leave your answers in simplest radical form. I'm going to show you guys how we can kind of convert that. And we might actually change some of these questions for the quiz just so you don't have to mess with the simplifying per se. But we'll get to that later. So first of all, I see, let's do this one, 12, 8, and something. I want to do 20 just because it has the x not on the hypotenuse. So when I'm doing something squared plus something squared equals something squared, this being the hypotenuse all by itself, the hypotenuse is 12. So that's going to go over there. 8 could go in either one of these, doesn't really matter. And x will be the third one. So x squared plus 8 squared is 64. 12 squared is 144. Now I'd subtract 64 from each side. So if I were to subtract 64, I'd wind up getting x squared equals, well, 4 minus 4 is 0. 14 minus 6 is 8. Or 140 minus 60, I should say, is 80. Okay, so now I'd have to square root these. And then here's the tricky part. X equals square root of 80. We're actually just going to leave it there. We're going to change some of these answers so that it's working more off this type of answer. But if you were to see something else, it would look like this. I notice that I have some perfect squares that would go into this. For example, square root of 16 times 5. And the square root of 16 is really 4. What does that tell me? That tells me that this could be 4 times the square root of 5. Now, if you were to type both of these things into a calculator, you would get the same exact approximation. So, and that's kind of weird, the same exact approximation. I know not a lot of people get that joke, but that's okay. These are equal. So on a multiple choice thing, you might see this, whereas this answer is still correct, maybe just not complete. For our actual quiz, I'm probably going to leave it more in the non-simplified version here. Okay, let's try some more. So now these next ones, these are a little bit interesting because it just says state if it's a right triangle. Well, if we know that two things squared equal, we're not sure, we're checking, the third one squared, then we know that it's a right triangle. Well, if I look at this, it looks like the 9 and the 8 would be these pieces, and the hypotenuse would be square root 145. So let's check that out. This would be 81 and 64. And here's the cool thing. When you square something that has a square root, it just takes away the square root. So if I were to add these two pieces together, 81 and 64, 80 and 60 is 140, 4, 1 is 5, so I got 145 equals 145. That's perfect. Yes, they're equal. Let's look at one that maybe isn't necessarily equal. So over here I'm going to do the same calculation. Something squared plus something squared equals maybe something squared. So we'll have 10, 12, and then the third one here is square root 241. 10 squared is 100. That's easy. 12 squared is 144. That's also pretty easy. But 241 square rooted and then squared is just 241. Here's what gets interesting, because they're not really equal. On the left side I'll get 244, and on the right side I'll get 241. Because they're not equal, then they're not a right triangle. Aha! So then let's take that one tiny step further, just one little bit. Okay, if it's not a right triangle, what kind of triangle is it? Well, it could be acute or obtuse. And the thing you're looking for then is the hypotenuse big or small? Because if you have a big hypotenuse, then that means you got obtuse. You got a big giant side with a big giant angle in there. If the hypotenuse is smaller than the other two pieces, then you got something that's more acute. So let's see what we have here. Again, we're going to have something squared plus something squared equals maybe, let's not say equals at all. How about let's just say is question mark to the third squared. Well, which one of these would be the biggest? 107 would be close to 10 square rooted, and 32 would be between 5 and 6. So this one squared would be 144. That's going to be my hypotenuse, or at least the long side. So I'm going to say that that's 144, because 12 squared is 144. How does that compare to square root of 32 squared is just 32, and square root of 107 squared is just 107. If I were to add these two things together, that would give me 139 versus 144. Okay, so clearly this number is bigger, but is that the hypotenuse? Or is the smaller one the hypotenuse? Well, the hypotenuse was the one that was by itself here. So that means that 144 the whole time is bigger. That means this, in fact, even though it kind of looks like a right triangle, is an obtuse triangle. Similarly, on the other side, with actually much smaller numbers, so that's nice of them to do for us, we have three pieces, and we're trying to figure out how they fit together. So we'd have something squared plus something squared is, I don't know, bigger or smaller than the third piece squared. The third piece, the hypotenuse over here, would be the 11 square rooted. Then we have square root of 6 and square root of 3. All right, square root of 6 squared is 6. Square root of 3 squared is 3. Oh, no, wait, that's not square root of 3 squared. That's just 3. So that would be 9. And then over here, square root of 11 squared is 11. So 6 plus 9 is 15. Okay, so this side is bigger. This side is smaller. And which one's the hypotenuse? Well, the hypotenuse we said was square root of 11. So that is smaller. The hypotenuse is smaller. That means it's acute. All right, we'll probably have the other video up later today, but that'll finish us out for now.